Ever wondered how medieval peasants fed entire populations without tractors or fertilizers? These farming masters developed agricultural techniques that often outperformed modern methods. Their innovations increased yields while building soil health. Crop rotation systems. Medieval peasants developed the three-field system that revolutionized agriculture by rotating crops to maintain soil fertility without chemical fertilizers. One field grew grains like wheat or barley, another grew legumes such as peas or beans that fixed nitrogen into the soil, while the third remained fallow to recover nutrients. This rotation prevented soil depletion while naturally restoring essential minerals. Legume crops added nitrogen that following grain crops could utilize, creating a self-sustaining fertility cycle. This system produced consistent harvests year after year without external inputs. Animal-powered cultivation. Medieval farmers maximized efficiency through strategic use of oxen and horses for field cultivation, developing harness systems and plowing techniques that accomplished heavy work without machinery. Oxen provided steady, powerful pulling for breaking tough soil, while horses offered speed and agility for lighter cultivation tasks. The heavy moldboard plow, pulled by teams of animals, turned soil more effectively than manual digging while covering large areas quickly. Improved harness designs like the horse collar distributed weight properly, allowing animals to pull heavier loads without injury. Multi-purpose livestock served various functions. Oxen plowed fields and provided meat, horses handled transportation and fieldwork while their manure fertilized crops. Hand tool innovation. Medieval craftsmen continuously improved hand tools that made farming more efficient and less physically demanding while achieving results comparable to modern equipment. The moldboard plow evolved from simple digging sticks into sophisticated implements with iron shares that cut through soil cleanly while turning it completely. Scythes with curved blades allowed farmers to harvest grain quickly with smooth rhythmic motions that covered wide swaths efficiently. Sickles provided precision harvesting for delicate crops while minimizing grain loss during cutting. Specialized tools served specific functions, mattocks for breaking hard soil, flails for threshing grain, winnowing baskets for separating wheat from chaff. Tool maintenance included regular sharpening using whetstones and proper storage to prevent rust and damage. These innovations transformed backbreaking labor into manageable tasks while increasing productivity. Natural fertilizer production. Medieval farmers created comprehensive fertilizer systems using animal manure, compost, and organic materials that enrich soil more effectively than many modern synthetic fertilizers while building long-term soil health. Manure collection involved strategic barn design and bedding systems that captured animal waste efficiently while preventing nutrient loss through drainage or decomposition. Composting techniques layered animal waste with plant materials, creating balanced fertilizer that provided slow-release nutrition throughout growing seasons. Green manure crops like clover or vetch were grown specifically to be plowed under, adding organic matter and nitrogen to soil. Wood ash from hearths provided potassium and other minerals essential for plant growth. Human waste was carefully composted and aged to eliminate pathogens while preserving nutrients. Application timing coordinated with crop needs and weather patterns to maximize nutrient uptake while preventing runoff. Different fertilizer types serve specific purposes: fresh manure for heavy feeders like cabbage, aged compost for delicate plants, ash for root crops needing potassium. These natural systems created fertile soil that improved over time rather than depleting through chemical dependency, supporting sustainable agriculture for centuries. Water management systems. Medieval farmers engineered sophisticated water management systems that controlled irrigation and drainage without pumps or modern equipment, often achieving better water efficiency than contemporary irrigation methods. Irrigation channels utilized gravity flow from streams or springs, directing water precisely where crops needed it most. Strategic channel placement followed land contours to minimize erosion while maximizing coverage. Drainage systems removed excess water from wet fields using ditches and tile systems that prevented waterlogging and root rot. Mill ponds served multiple purposes, providing water power for grain grinding while creating reservoirs for irrigation during dry periods. Terracing on slopes prevented erosion while creating level planting areas that retained moisture effectively. Rainwater collection involved positioning buildings and surfaces to channel precipitation into storage areas. Seasonal flooding was managed through temporary dikes and channels that protected crops while utilizing flood nutrients. Water distribution used wooden gates and stone channels that could be adjusted based on crop needs and weather conditions. Maintenance protocols kept channels clear and functional throughout growing seasons. These systems provided reliable water management that sustained agriculture through droughts and floods, while preventing soil erosion and nutrient loss that plague modern farming operations. Seed selection and saving. Medieval peasants developed sophisticated seed selection and preservation techniques that created locally adapted crop varieties with superior performance characteristics compared to many modern hybrid seeds. Selection criteria included choosing seeds from plants that demonstrated disease resistance, high yields, early maturity, and adaptation to local climate conditions. Multi-generational selection gradually improved crop performance while maintaining genetic diversity essential for resilience. Storage techniques involve thorough drying to prevent mold, sealed containers to exclude pests, and cool, dry locations that maintain seed viability for multiple years. Different storage methods suited various seed types: root fix, grain seeds in clay pots, root vegetable seeds in sand, herb seeds in cloth bags. Community seed sharing created regional seed libraries that preserved multiple varieties while enabling farmers to experiment with new crops. Knowledge transfer included teaching younger generations about seed characteristics, selection techniques, and storage methods that preserved valuable genetic resources. Quality testing involved germination trials that verified seed viability before planting seasons. Record-keeping tracked which seed sources produced best results under different conditions. Heritage variety development created crops perfectly adapted to local soils and weather patterns, often outperforming modern varieties in specific environmental conditions, while requiring no external inputs for consistent performance year after year. Intercropping. Medieval farmers perfected intercropping systems that maximized land use efficiency while creating beneficial plant partnerships that improved yields and reduced pest problems without chemical interventions. The Three Sisters planting combined corn, beans, and squash in mutually beneficial arrangements. Corn provided support for climbing beans. Beans fixed nitrogen that fed corn and squash, while squash leaves shaded soil and deterred pests with their spiny texture. Companion planting utilized natural plant relationships that enhanced growth and protection through chemical interactions, root relationships, and physical compatibility. Aromatic herbs like basil and oregano repelled insects when planted near vulnerable vegetables. Deep-rooted plants brought nutrients from subsoil layers to benefit shallow-rooted companions. Different plant heights created layered growing systems that utilized vertical space efficiently while providing beneficial shade and wind protection. Nitrogen-fixing plants like legumes improved soil fertility for neighboring crops throughout growing seasons. Sequential planting staggered harvest times while maintaining continuous soil cover that prevented erosion and weed growth. Pest control occurred naturally as diverse plantings confused pest insects and provided habitat for beneficial predators. Space optimization techniques fit multiple crops into limited areas while ensuring each plant received adequate nutrition and growing space. These polyculture systems created stable, productive agriculture that sustained communities while building soil health and ecological resilience that monoculture farming cannot achieve. Pest control without chemicals. Medieval farmers developed comprehensive pest management systems using natural methods that controlled agricultural pests more sustainably than chemical pesticides while building long-term ecological balance in farming systems. Beneficial insect attraction involved planting flowering herbs and native plants that provided habitat and nectar sources for predatory insects that naturally controlled pest populations. Physical barriers included cloth covers, ash applications, and companion plants that prevented pest access to vulnerable crops without harming beneficial organisms. Crop rotation disrupted pest life cycles by removing host plants during critical reproduction periods, breaking pest population buildups that occur in continuous monoculture systems. Natural repellent preparations used aromatic plants, soap solutions, and organic compounds that deterred pests without toxic residues or environmental damage. Trap crops attracted pests away from main crops, concentrating damage in sacrificial plants that could be removed or destroyed. Biological control encouraged natural predators through habitat management and avoiding practices that killed beneficial organisms. Timing strategies planted crops when pest pressure was naturally low or harvested before peak infestation periods. Soil health management created strong plants naturally resistant to pest damage through proper nutrition and growing conditions. Integrated approaches combined multiple control methods that provided comprehensive pest management without relying on any single technique. Community cooperation coordinated pest control efforts across farms to prevent pest migration and population buildups that could overwhelm individual control efforts. These natural systems maintained ecological balance while protecting crops effectively, creating sustainable agriculture that supported both human needs and environmental health through centuries of continuous use. Harvesting and processing techniques. Medieval peasants developed efficient harvesting and processing methods that maximized crop recovery while minimizing labor requirements through strategic timing, community organization, and specialized techniques that achieved results comparable to modern mechanical harvesting. Hand harvesting methods utilized proper cutting techniques and timing that minimized grain loss while maintaining quality throughout the collection process. Scythe techniques involved rhythmic cutting motions that covered maximum area, while maintaining cutting efficiency and reducing physical fatigue during long harvest days. Community work organization created harvest crews that combined labor resources to complete time-sensitive harvesting before weather damage or over-ripening reduced crop quality. Task specialization assigned specific roles based on individual skills and physical capabilities. Strong workers handled heavy cutting. Detail-oriented workers gathered fallen grain. Experienced workers made quality decisions. Sequential harvesting prioritized crops based on maturity and weather resistance, ensuring optimal timing for each crop type. Grain processing techniques included threshing methods that separated grain from stalks using flails and trampling, followed by winnowing that removed chaff using natural wind or created air currents. Storage preparation involved proper drying to prevent mold, pest control measures to protect stored grain, and container systems that maintained quality throughout storage periods. Quality assessment identified damaged or inferior grain that required separate handling or immediate use. Processing efficiency utilized specialized tools and techniques that maximized output while minimizing waste throughout the grain preparation process. Weather coordination timed harvesting activities around rainfall and humidity that affected crop quality and processing efficiency. These traditional methods achieved remarkable efficiency while maintaining grain quality that sustained communities throughout the year without mechanical equipment or external energy inputs. Soil building. Medieval farmers developed comprehensive soil management systems that built fertility and prevented erosion through natural processes that often created more productive and sustainable growing conditions than modern industrial agriculture. Terracing techniques transformed steep slopes into level growing areas that prevented erosion while creating optimal growing conditions for crops that required specific drainage and sun exposure. Construction involved stone walls, earth berms, and drainage systems that controlled water flow while preventing soil loss during heavy rainfall. Organic matter incorporation included systematic addition of plant residues, animal bedding, and compost materials that improved soil structure while providing slow-release nutrition throughout growing seasons. Cover cropping utilized plants specifically grown to protect and improve soil during fallow periods, preventing erosion while adding organic matter and nutrients when plowed under. Green manure crops like crimson clover and winter rye provided nitrogen fixation and erosion control during seasons when main crops weren't growing. Soil testing involved observing plant performance, soil color and texture changes, and earthworm populations that indicated soil health and fertility levels. Natural amendments included wood ash for potassium, bone meal for phosphorus, and compost for balanced nutrition that improved soil chemistry without synthetic inputs. Crop residue management returned organic matter to fields while preventing disease buildup through proper composting and timing. Pasture integration rotated livestock through fields that added manure while preventing overgrazing that could damage soil structure. Water management prevented both erosion and waterlogging through strategic drainage and retention systems that maintained optimal soil moisture. These soil-building practices created fertile growing medium that improved over time rather than depleting, supporting continuous agriculture for centuries while maintaining productivity that sustained entire communities through natural soil fertility enhancement rather than external inputs. Community farming systems. Medieval peasants organized sophisticated community farming systems that pooled resources, knowledge, and labor to achieve agricultural success that individual farmers could not accomplish alone while creating social structures that supported rural communities throughout challenging periods. Cooperative labor organization coordinated seasonal work efforts that brought together multiple families during critical periods like planting and harvesting when timing was essential for success. Task allocation distributed work based on individual capabilities, available resources, and crop requirements that ensured optimal use of community labor while maintaining social equity. Shared resource management included community ownership of expensive equipment like plows, mills, and draft animals that individual families could not afford independently. Tool-sharing programs maintained agricultural implements through cooperative ownership and maintenance that kept essential equipment functional and available when needed. Knowledge transfer systems preserved agricultural wisdom through mentorship programs that connected experienced farmers with younger generations, learning traditional techniques and local adaptations. Problem-solving cooperation addressed agricultural challenges through collective experience and resources that provided solutions beyond individual capabilities. Seasonal coordination synchronized farming activities across the community that optimized labor use while ensuring all necessary work was completed efficiently. Mutual support networks provided assistance during illness, crop failures, or other emergencies that threatened individual family survival. Seed and breeding programs maintained genetic diversity while improving crop and livestock performance through selective breeding and variety preservation. Market coordination organized collective selling that achieved better prices while reducing individual marketing costs and risks. Social integration connected farming activities with community celebrations, religious observances, and cultural traditions that reinforced cooperative relationships essential for agricultural success. Risk distribution spread weather and pest risks across multiple families while providing security through shared resources and mutual assistance. These community systems created resilient agricultural networks that sustained rural populations through centuries of challenges while maintaining productive farming that fed both local communities and broader populations through cooperative effort and shared knowledge rather than individual competition. These medieval farming techniques prove that traditional agriculture achieved remarkable productivity through understanding natural systems rather than fighting them. Their methods often produced better soil health and sustainable yields than modern industrial farming while requiring no external inputs or fossil fuels. Ready to discover more agricultural wisdom that could transform modern farming? Subscribe for weekly insights into sustainable techniques that work with nature.